Okay, we're continuing our study of AC theory, and before we continue onto the actual circuits, we need to make sure we have a good understanding of trigonometry and Pythagoras' theorem. The study of AC theory involves us using equations from trigonometry quite extensively, so you have to understand when to use them, why we're using them. So we've got a right-handed triangle on screen right now, and we're going to spend some time just labeling it. So let's say that we're provided an angle here, and we'll call this angle theta. Okay? We have two angles so far, and we have a third that we haven't been provided. We can actually start to label this triangle based on this angle, on these angles. So the first thing we're going to do is we're going to label this side length here, that is directly opposite the 90-degree angle, the largest angle in this right-hand triangle. This side length is called the hypotenuse. I'm going to just write HYP for short. Okay. The next side length that we're going to consider is the one that's directly opposite this angle theta. It is directly opposite this angle theta. Okay? And it is called the opposite side length, OPP. Let's write that a bit bigger. OPP. It's the opposite side length. What I should have done was written this in purple. This is the hypotenuse. This is the hypotenuse. HYP. Just had to switch colors there. The final side length that is present in a right-handed triangle is the one that is next to the angle that has been provided. It is adjacent to this angle theta. And this side length is called the adjacent. Now let's put these side lengths into use and start writing out some identities that we need to know. So I'm sure that in VCE or year 12 or year 9 or year 10 or year 11 mathematics, you would have been introduced to these following identities. Sine theta, cosine or cos theta for short, tan theta. Okay, let's write out what these actually have to do with these side lengths. So to find the sine of an angle in a triangle, what you need to do is take the opposite side length, this one here, the opposite side length, and divide it by the hypotenuse's side length. A common way that people remember sine theta is to say that sine theta is equal to O over H, and then they simplify this into SOT. I'm sure you can see from here that sine theta is equal to opposite O divided by hypotenuse. Okay? So that's the first one, identity that we need to be aware of. Next is cosine. Cosine is going to be the adjacent side length divided by the hypotenuse. This can be simplified into cos theta equals adjacent over hypotenuse. And that means that you can write it as CAH. C-A-H. Again, what that means is that cosine, the C there, is equal to the adjacent divided by the hypotenuse. The final trigonometric identity that we need to be aware of, tan theta is the opposite side length divided by the adjacent side length. And we can simplify that into tan theta is equal to O over A. And again, to make it easy, you can just remember the word toa. So ka toa. And toa means that tan theta is equal to the opposite divided by the adjacent. Okay, let's say we're provided a triangle similar to that above, where we're told that the angle theta is up here, and that the hypotenuse has a side length of 10 meters, and we're told to find x. And in this question, we're going to say that theta is equal to 40 degrees. So pause this video and have a crack and see if you can work out what the side length x is. Okay, so the first thing that you should be doing when it comes to these is just labeling your triangle. So it tells us that in the side length that's opposite this right angle is a hypotenuse. So this guy here is the hypotenuse. It says that the side length that is directly opposite angle theta is our opposite side length, and that the side length here that is adjacent to our angle theta, right next to it, is our adjacent side length. So with that in mind, what side length are we actually trying to find here? We're trying to find the adjacent side length. So when we have the adjacent side length that we're trying to find, and we've been provided with the hypotenuse side length, we should be using ka. This is going to be a ka question. Ka means cos theta, which is the adjacent side length that you're trying to find, divided by the hypotenuse. Okay, let's start filling in the information we know. So we've been told that theta is 40 degrees. So we can say that cos 40 degrees is equal to, do we know what the adjacent side length is? At this stage we don't, so we're trying to work out. So we'll just write x. Do we know what the side length for the hypotenuse is? Yes, it says here it's 10 meters. We can work out x by multiplying the 10 onto this side. So multiply both sides by 10 meters. That gets rid of it on that side and moves it over to this side. So our side length for the adjacent in meters is going to be 10 times cos of 40 degrees. Let's bring up our calculator. Ten times cos of 40 degrees. It says that it's 7.66 if we do it to 2 decimal places. 7.66 meters.